So for example, what is, no. So if you had something like 2x plus x plus 1 square equals what? You know, like those, you have like polygons, you try to find, for example, find roots and stuff like that. You're all familiar with those kind of things, right? So you try to find out like what can I apply to kind of resolve that and so on. So this is pretty much the same thing. We try to apply any of these rules. We had that, and some of them. So the inference rule, the inference rules always have like this, basically this implication in here. The equivalence rules are like, what can I write differently? So for example, we have the distributive laws, and that's what's on that handout that I gave you. You might just keep that and look at the different laws that are very or rules that are very similar to other arithmetic formalisms or other formalisms. For example, like arithmetic operations, plus, minus, times, and multiply. So these are all examples, and you might actually go, it's kind of with your handout, and try to see what has been done. So how to prove this particular argument, and the pattern depend. So that's basically what the idea of the exercise was. The first step is you take a verbal argument, create a formalism from that, and then from that formalism, you try to resolve it, so that by the end, you basically end up with this. You want to end up with this conclusion. How can we derive that? Do you guys have your handout handy? Because it's sometimes good to know which of these are what. So we have the arguments here, our hypothesis, and these could come from verbal arguments, like the examples that we had. And now we basically need to see how can we solve it. What can we produce? So if, for example, if we take so this here's our first hypothesis. This is the second. The third hypothesis is kind of lengthy. And then this is the fourth hypothesis. So if we look at the candidates, so which, kind of like a puzzle, which pieces can we work with? What applies? And things we're looking for is, for example, one of the most popular things is the modus ponens, which is this here. So this is modus ponens. And it looks crappy. What does the modus ponens rule look like? There's one of that you might want to remember by heart. It's used a lot. So the modus ponens is. Does anybody have it there? A, we can use A or B. Let's use P. So basically, it starts out with if P implies Q, so we use the standard if then rule, and we know the condition is true, basically, and P. So we have a rule or like a hypothesis that says P implies Q, and P is true, then we can conclude that Q is also true. So this is almost probably the most popular inference rule and most likely to be applied to something. That is called modus ponens, MP, and we use it all the time. There's actually a counterpart, which is called the modus tollens. Modus tollens, and that is basically the negation. If P implies Q, and we know that Q is not true, that implies not P. This is one of my favorites. This is one of my favorites because it's there's a very touchy, but there's a very powerful argument behind that. So if the argument is like, let's pick any CSI or Law and Order episode. If, let's say, P is let me make sure I put it the right way. So let's say we have let's take a CSI. We have blood at let's say we have blood at a crime scene, and of the perpetrator. So if we arrest somebody, if that person is that we arrest is the perpetrator, then the blood should match the DNA sample. Should do a DNA match on the crime scene. It could be blood or even hair, whatever they have now, skin cells. So if we have the perpetrator, we have a DNA match. So what is often done is portrayed is that that people say, okay, the suspect is guilty because the DNA matches. But that's not really true, because there could be many people. If you have a DNA sample, there are a lot of people who could be a match. So that implies basically that the perpetrator will match the DNA sample that was found. Is a hypothesis that's true, but the only conclusion we really can make safely is if there is no match. So if P implies Q, perpetrator will match DNA sample, but the DNA test does not match, then the person is not guilty. So we can use DNA samples to rule somebody safely out. Well, this person cannot be it because the sample does not match. But we can't do the other way around, as it's often portrayed. So the modus tollens would be the this here would be the an argument for that if we say we all apply, okay, if the person is guilty, then the DNA should match, but the DNA does not match, then the person is not guilty. We can safely conclude that. If we have if the person is guilty, the DNA matches, and the DNA matches. That does not allow us to arrest the person. or to basically, or to give a verdict, to judge the person. So that's like, you know, when you on the typical CSI, what I try to, or like, you know, popularly what we try to portray is, we say P implies Q, and then we say, and there was a match. Does this imply the person is guilty? And if we put this into a formal argument, now you can actually, maybe that's a good exercise, see if this actually is true. So how can we can solve that? Actually, maybe just do it on the board. I think that's easy.